So, good morning, buongiorno. Thank you for inviting EUSPA to participate in this important event. It's a pleasure to be here in the city of Bari. So my keynote speech is going to address this topic, future of space data and services for innovative aerial services. A few, Okay, so a few words on our agency. I work for EUSPA, which is an agency of the European Union Agency for the Space Program. So it is the formerly known GSA, GNSS Supervisory Authority, but now new elements of the EU Space Program has been transferred under the responsibility of EUSPA. So we are in charge of the exploitation of a couple of elements of satellite navigation, EGNOS and Galileo, also Copernicus, the EU space program, and also communications, GovSatCon, and space situational awareness. So there is a wide variety of space programs under the responsibility of EUSPA. I will focus on the first three elements, so GNSS, EGNOS, Galileo, and Earth observation. How can we connect these systems to the needs of the drone community? So, well, in the presentation from the representative from the European Commission, he explained in detail the Drone Strategy 2.0. It's a public document, was published in November last year. So, going through this document, we have identified in particular some references to EU space assets. So there are specific objectives and actions. You can see there, for instance, services and data of the EU space programs, and a specific mention to EGNOS, Galileo, and Copernicus, connected to the needs of the drone community. Also some keywords, resilient and robust drone navigation. So there are many, it's embedded. EGNOS, Galileo, and Copernicus, the EU space programs are embedded in this Drone Strategy 2.0 from the Commission. So as a result of this, we have at EUSPA, we have developed a strategy with all the member states of the EU and other agencies. For instance, we are working with EASA, with the European Maritime Safety Agency, the Fisheries Control Agency, Eurocontrol, European Defense Agencies, and other agencies. As a result of this, we have, as I said, developed this strategy. And we have identified for the time being 30 actions, and we have grouped it into 4 clusters. So as you see, we have, for example, the first cluster is drone operator support. So we have a number of actions, training material, guidance material, if you may raise questions or you are desired problems, and we will take care of your questions. We have specific facilities in the GNSS Service Center, which is an infrastructure of EUSPA. And also ESSP, the EGNOS operator. So they have groups constantly testing how EGNOS and Galileo are actually supporting the needs of drone flight operations. Cluster number 2 is GNSS performance requirements and services for drones. For instance, here we are assessing the requirements of the drone community, trying to quantify, for instance, continuity, availability, all these requirements. For instance, in the case we are using EGNOS, as you know, EGNOS was developed for manned aviation. And now we have to use this. If we want to use this system for a different flight operation, we need to understand that, of course, a drone is not flying an LPV approach. It's flying a different flight operation. Cluster number 3 is where we are addressing Copernicus. I have a specific slide on what we can do with Copernicus for drone operations. And in cluster 4, we are addressing, in particular, 2 differentiators of Galileo, the high accuracy service and the authentication service, the OSNMA. Also, we are in constant dialogue with the many market sector communities, not only drones. We are talking with agriculture, maritime, railways, but in the particular case of aviation and drones, for the time being, they are together, conventional aviation and drones. The last user consultation platform that we organized was held in Prague, in the Czech Republic, last year. And as a result of our dialogue with the drone community, we have produced this document that you have on the right-hand side. You can download this document from the web, and here you have some requirements or assessment on how EGNOS, Galileo, and Copernicus are supporting drone flight operations. This year, 2023, the European Union Space Week is going to be held early November in Sevilla, in Spain, but we don't have a UCP, a user consultation platform for aviation and drones. We will have a specific session next year, 2024, and we will address aviation drones and a new entrant hubs, the high-altitude platforms, in a specific UCP, in order to extract user requirements from the operators, from the authorities, and try to ensure that the EU space assets are actually well connected and are evolving in response to the user needs. And now I have prepared a couple of slides, one on GNSS and another on Copernicus. What's the connection between GNSS and drone flight operations? Well, it has been previously discussed in the previous interventions. Of course, we need to refer to the EASA taxonomy. So the wider concept is, the title of this event is Innovative Aerial Services. We have aerial operations and we have innovative air mobility. So the big goals are unmanned aircraft and the VTOL-capable aircraft, so the air taxis. So GNSS is actually at the heart of drone operations. And well, you can see there a drone, find a trajectory. So we have identified three main areas of relevance of GNSS for drone operations. First of all, obviously, drones, the position determination for find a given trajectory. This is applicable within and outside US space, airspace, in all risk categories. So from the simplest drone to an air taxi, it's very likely that there will be using a GNSS sensor for the position determination function. Also, we have reporting of the position, we have geo-awareness, we have collision avoidance functions. And the third element is mission-specific applications, and this is a huge area of activity where we are, for instance, using GNSS for geotagging of data or an image collected from or taken from a drone. If we go into in details of EGNOS and Galileo role within GNSS, of course, typically the sensors are multi-constellation, multi-frequency, including Galileo. Galileo is already embedded into more than 50% of the sensors available in commercial drones. We have EGNOS enabling improved positioning accuracy, sub-meter accuracy on a continental base in Europe. And so we are using an increased accuracy, and also we are studying in detail the integrity feature. This is, again, EGNOS was designed to support flight operations of airplanes, so something equivalent to an ILS, but here what we want to determine is the region of uncertainty in real time around the estimated position, considering that the drone is not flying, obviously, an LPV approach. Concerning the differentiators of Galileo, we have this high accuracy service. If you read the documents of the HAS, we have horizontal navigation system error 95% of the time, in the order of 20 centimeters, but this requires open sky conditions. So we are assessing the use of HAS in a bit more degraded environments where we have some buildings and multipath and other degraded environments. And also, in a number of several projects, we are assessing the authentication, the open service navigation message authentication, because this is actually supporting many potential business cases, because you may have a position with legal validity. So there is a significant business case. It's not technology for the sake of technology. It's technology in response or connected with the needs of the drone community. And concerning Copernicus, well, as you know, Copernicus is also a huge program. We have 6 services. We have been, well, for some years, thinking on connecting Copernicus with drone applications. And the good thing is that this can be used as a pan-European trusted solution for, in particular, for 2 applications. The number one is top priority. We are working a lot on that. Is the determination of the intrinsic ground risk class in the SORA process to determine the population density. So for that, we may be using the Copernicus Global Human Settlement Layer. I stress that this service is offered worldwide for free, and it is actually being used today for SORA assessment, for instance, in the case of Poland, other experiences in Switzerland, I think here in Italy, so in Germany. So it's already being used in the SORA process, okay? And it's being used by the drone operators and accepted by the pertinent aviation authorities. And the second element is to the assessment of the terrain and obstacles in the area of operations. So for that, we have this Copernicus digital elevation model. So there are other applications of Copernicus, but for time being, we are working hard on these 2 lines of action in response to the needs of the drone community, in particular in the first one. You may know that EASA organized a workshop on population density the 6th of October, and detailed information is available in the EASA website if you want to go into the details of this application of Copernicus. And that's also, to conclude, I would read the motto of EUSPA, linking space to user needs. This is our mission, where we are contributing to in the field of drones. So the intention is actually to support, to facilitate the wide-scale adoption of innovative aerial services across Europe in the short term. Thank you.